What's going on, guys? So in this video I'm going to be water cooling my bed. To do that I need to wire up this, well, it's actually sold as an aquarium cooler, but it's just a Peltier module with a temperature controller. So this is the temperature module that it comes with, but the firmware is locked out and I can't into heating mode. So what I've done is I went ahead and bought one of these small, basically it's just a relay, two relays, and it switches between heating and cooling. I think it's for refrigerators. The way that I'm going to make this work is I want to be able to heat and cool the water flowing through this little water block here. It'll make more sense later on when I show you the finished project, but with Peltiers, they're basically like a solid state heat pump, pass current through them, and one side gets hot, one side gets cold. If you reverse the polarity, like the voltage, reverse the positive and negative, it switches which side gets hot, which side gets cold. So I'm going to wire it up to this temperature controller, so I can either set it to heat the water flowing through the water block or cool it, or keep it at a set temperature by alternating between heating and cooling. And to do that, the relays in here only switch a single pole, so they can either switch the positive or negative on or off, but I can't really reverse it. To combat that, what I went out and got was some double pole, double throw relays. They just use a 12 volt coil in them, so I can power it all off 12 volts, the whole system. And basically what I'm going to do is, this is upside down, but so normally this just has has heating and cooling outputs, and it basically just connects one terminal to the other terminal. Like you'd put your negative rail or your positive rail there and it's switched on and off. But because I want to be able to reverse the polarity, all I'm going to do is have, say, on the input, pin 5, I'm going to have 12 volt positive, and then on the output I'm going to have that's just a switched output, sorry. And that's going to turn the relay on, and then the relay itself, I'll be able to switch the polarity that way by reversing which pins are on the output here, either switching positive or negative. The second relay, it'll sort of be wired up like this, if that makes any sense. So I'm going to go ahead and do that, and I'll be back in a little bit. Okay, so I'm just going to explain this a little bit better. So this is the relay I'll be using this one for the cooling mode. So basically these two pins here are for the solenoid, basically this big coil in here. Apply 12 volts across that and it activates. I believe this is a latching relay, so it just goes back to, stays in the position that you left it, I guess. I have to test it some more. So the two center pins are basically, they'd be 12 volts and ground, and then when you apply voltage across the coil, this snaps into place. I believe with this one, these two contacts are always connected to this when it's powered off, and then when you apply current to the coil, it switches from powering these two pins to these two. So all I have to do is wire up 12 volts to here, output goes to here, which is going to the Peltier, and depending if it's the cooling or heating side, just reverse which one's positive, which one's negative, and that'll let me reverse the polarity on this and keep all the functions. So yeah. Alrighty, so I've got one of the relays all wired up, ready to go, and this is how it's going to work. I could have just removed these two relays and drilled some holes and cut some traces to fit these ones in, but the only issue with that is I don't have a drill bit small enough for those holes. So I just did it this way, which is a bit more modular. It takes up more room, but I think it works just as well. So the way this is going to work is when one of these switches on, they can't switch on both at the same time. The software doesn't allow that. So if it's in cooling mode, it switches on one relay. If it's in heating mode, it switches on the other relay, because one's meant to drive like a compressor and the other one's meant to drive a heater, but we're kind of doing it a bit backwards and making it drive the same thing, just one way in reverse, which does the same effect. So I removed the screw terminals and put in some JST connectors here. They'll have a common ground, which will just be the input ground. I'll wire that up in a sec. And they just get plugged into a JST connector. On the relay, I'll glue it down as well to make it nice and strong. So when that's connected, the relay turns on and puts 12 volts through the coil. The coil then switches from these terminals to these ones, and that'll turn on the Peltier. And then for the output, I've just gone ahead and reused those screw terminals that I took off the board here, just to make things a bit easier to wire up and a bit more sturdy. And I'm just using some thick wire here. It's off a computer power supply. It is rated at 20 AWG. This is originally off a computer power supply for the 12 volt CPU connector. Ooh, I think that usually carries a maximum of 120 watts. The Peltier I've got is only 100 watts, and the power supply anyway can't put out that much. It's just a crappy Chinese power supply. I have no idea actually how much current it puts out. I might replace it with something like a computer power supply or an Xbox 360 one. So yeah, that's the little modular relays, and hopefully it can fit all back inside this box. I'll have to Dremel or hacksaw out the original display so the replacement one can fit. I also removed the beeper out of it. It makes a very loud beep whenever you press a button, and you don't really want that next to your bed. So yeah, be back in a little bit. Alrighty, so all the wiring's done, apart from the fan. The fan I'm going to make a separate power supply for later. Probably like a 9-volt supply or something for it, just because if I tap off the back of one of these relays, I only want the fans running when it's cooling. So might just add a third relay. I've got 3 of them, just because I don't want when it's running in heating mode for the fans to be the polarity of the fans to be backwards, just in case. And also I want to run them at a slightly lower speed. There isn't much performance increase in the cooling running them at full speed compared to like 70%. So that's something I'll fix in another day. For temperature control, they come with these little thermocouples. I think they're just normal K-type ones that are just potted so you can put them underwater. But to sort of avoid thermal runaway, just in case the pump fails, I'm going to mount it on the bottom side of this, of the actual water block. Whoops. The water block down in there. That way, if it does start to overheat or whatever, it'll cut it off straight away, or I'll switch it into cooling mode at least. And I'll probably just stick it down with some thermal adhesive. When there's water being pumped through it, it'll pull out most of the energy out of the water anyway, so it wouldn't be constantly turning on and off. I can also set a margin on the crossover point, like a 3 degree or 5 degree or 10 degree. It has to change by at least that amount, say 5 degrees Celsius, before it switches into the other mode, which I'm going to set anyway, just in case these relays are a bit slow, smoke and all that. So yeah, let's try it out. Okay, so this is the finished setup. There's a 1-minute delay between cycles because it's really intended to run a compressor, not a air, so it's just to save. It's just to protect compressors. I'll have to try and see if I can disable that or make it shorter, but there's a 1-minute delay anyway. Because there's no fluid running through it, I just stuck the thermocouple inside the heatsink, and this will give us a rough idea of how it's going to function. As you can see, the cool light's flashing, but it's not actually cooling yet. It's counting down till it can start cooling, and the set temperature is like 1 degree or something. So then the cool cycle starts. I just put the fans on the same output as the cool side, so they run when it's cooling, and as you can see, it's dropping down pretty quick because there's pretty much no thermal mass in the unit at the moment. So this will probably overshoot and then switch to heating mode for a second, and then switch off, and then sit in standby for a minute until it needs to cool again, like now. As you can see, heating mode activated, the other relay clicked over, so now it's running in heating mode. That turned off, the 1-minute timer started again, and yeah. When there's water flowing through this, it'll be less on and off all the time, and if I can work out how to change that, if I can turn off that compressor delay, then we should be good. It doesn't matter anyway. Once there's fluid running through it, I think it's about 4 liters of water for the entire pad, so there's enough thermal mass in there for this to sort of even out. Running in cooling mode, I don't think it's going to ever really need to switch over that often. There you go, it's been a minute. Alrighty, so excuse the noise, but I've just got the thermocouple, or the thermistor, curing away there. I just used some solder mask and just tacked it down temporarily with some of this UV resin that I have as well, a different type of resin that sets faster, just because this stuff takes ages to cure, and that way it should stay there regardless of what temperature it is. I also picked up a pump. It did come one of the kits for the, I think it was for the chiller, came with a pump, but it was a mains voltage one, and I don't really trust it. So I just went out and bought one of these little tabletop ones, which is just 12 volts, which is also handy because I can add a second output to this thing, which is also 12 volts, and just run it off one power supply. Again, there's the relays. The fan, I'm going to try and see if I can salvage a 5-volt regulator for them and just throw that in, and it doesn't really matter if it's reverse polarity, I don't think. If it breaks, whatever. Oh, and when I was test fitting the pump, it got stuck inside, so I'll have to pull that back out. And this is the water thing reservoir that I got for it. I was trying to find something that had a big enough hole, like lid, to fit the pump and everything through, because I just want to have it sealed so I can just drill some holes in the lid and then run the wire and the 2 pipes out. Yeah. Okay, so I've got it all back together, well, sort of. That's where the module's sitting in there now. And I could probably see if I can squeeze the wires around a little bit more and make it fit. Otherwise, I can either leave it sitting out the front like this, or I can find some longer screws and bring the case out to match it, and then just seal around the edge with some tape or something to make it look neat. But that's pretty much where we're sitting now. I'll make an all-in-one unit, make it look super tidy, and then the 12-volt output here, I don't know if I'll use a separate plug or not for the pump. It'd be nice to be able to use the pump, just power off one wall outlet, but I don't know if this is good for that. It's probably running at its limit now anyway, so but yeah, the maximum delta, or the maximum differential between the air temperature, the room temperature, and the output of this is 40 degrees. So this will get down to probably minus 20, 22 or something like that. And yeah, but the whole idea is to make it look super neat and tidy and not look like a bomb. So yeah, hopefully turns out okay. Oh, and also I like the fact that the power button turns the whole unit off, so yeah, cool. I ended up finding the little rail clips that sort of clip this module around whatever front panel it's stuck to, so that made things much easier. I have also managed to get it to close up pretty much all the way. I could probably squeeze it in a little bit more, but I just don't want to damage anything, so it's just sort of just like that. Doesn't matter if any air leaks around it because it's yeah, it shouldn't hurt anything. And that's the back, so it's all one fully included unit, so it does heating and cooling. Yeah, and the fan is just set to the cooling side, so cool beans. Now I have to set up the pump and it should be done.
6 months later.
It's been a few weeks, and I sort of just put this aside for now, but I tested it out and it works alright for cooling, but for heating, because the fan isn't running while it's in heating mode, it's not moving enough thermal energy to heat the water up. So I went out and bought 2 of these little, they're just voltage regulators, but they're just switch mode ones, so they take up a little bit less room and make less heat. I'm going to attach the fan to them so I can run the fan constantly just at a lower speed, and maybe I'll mount it in a way that I can adjust the speed from the outside just using a screwdriver, which I think I might actually do that to prove it better. I also tried it with an aquarium pump. I think I showed that before, but yeah, it didn't really move enough water to make it work properly, so I just went out and bought a PC cooling pump, which moves, it's rated at 800 litres an hour. That little aquarium pump was only 120, so it should be more than enough, and it has a little reservoir on the side. I'll be able to mount it to the side of this somewhere once it comes, so I can plumb it all in and make it nice and neat. Yeah, I'm going to crack this open and install the little modules. Okay, so this is how it's going to be wired up. I just cut a hole in some heat shrink and put it over the little module, so that way it's a bit safer to adjust the voltage just by using a screwdriver. And then I'm thinking about I need one for each fan, just the way it's wired up. I can't run 2 fans off one thing. So I'll just mount them in the front like that, something like that, and then or even just drill a hole down here somewhere. The wires are long enough, and then just have one for heat fan and one for cooling, so you can adjust the fan speed for both, like just to control the noise and things like that. And basically it just goes off the back of the switch for each fan input. And because the way this is switched, if I just did it off the single 12 volt rail, the fans would always be running even when the thing's turned off. I'd like to be able to have this turn everything off at once, just with the little power button in the front rather than unplugging it every time. So yeah, hopefully that should work out well. Okay, so it's all wired up now. Just set the temperature, I think, to like 25 or something. So this is how it runs when it's in cooling mode. Chill down and then switch over. Heating mode switches over instantly, whereas cooling mode has a 1 minute delay. I can't make it any shorter than that. That's pretty much how it is. It won't bounce around as much either once it's all hooked up with the water, just because there's a longer delay between the temperature changing, and the temperature is measured just directly off the water block like I showed before. So yeah, I set the heat fan to be a little bit lower than the cooling fan, just because it doesn't need to move as much energy. It just needs to warm the water up rather than get it really hot. And the cooling fan is obviously higher just because it's going to have to work harder to keep it cool. Alrighty, so it's about a week later and I have the pump. Here it is. It's pretty schmick. And I just used some Kwikset UV resin to hold these little clamps on. I just scuffed it up with a wire brush, the plastic, and it's on there pretty tight. And I also just put an L bracket and screwed the little mount in the bottom. I was going to put a switch in it and power the pump off this main power supply. It'll add an extra 19 watts to the draw. I don't know how much power this little socket can handle, and I don't have any switches, so I'll just wire this up separately for now, just to a 12 volt power adapter, and it should be okay. Okay, so here's the general sort of layout of how the pump will work. So this top one here, pretty convenient that it's at the top. That'll be the return from the pad, from the cooling pad. So it makes it a bit easier because gravity and stuff. And they'll go back down into here. And then the outlet of the pump will go into the water block. And the outlet of the water block will go back up to the cooling pad. So hopefully this will be strong enough to cool it. Should be strong enough. And like I mentioned just now, this will be going to a separate power plug because I don't want to dry run the pump by accident or anything. So it's just easier if this is physically on a separate plug. Anyway. Should be finished soon. Alrighty, so I've got it all set up here on the bed now, and when I'll actually be using it in summertime, I'll probably have a sheet over the top. I have it set to 30 degrees, which is, it sounds warm, but when you're lying on it, it feels a lot cooler than that. It's cooler than your own body temperature anyway, so it should hopefully be nice in summertime. But this is what the mat looks like when it's fully filled up with water. The pump I bought is a bit loud. It's only running on 5 volts at the moment, but even just now while it's running in sort of standby where it's just the pump running and the actual cooler is switched off because it's at the set temperature at the moment, it's pretty cool. For heating and stuff, running it in reverse like that seems to work okay. It gets it fairly warm. It takes a little while to warm up. I might replace the heating side with like a PTC, like just a normal heating element for winter time, but I don't know if I'll need that or not. This is more just like a fun experiment to see how it will go. I might upgrade it at a second Peltier to make it cool a bit faster, but yeah, right now it seems fine. I think it's sitting about 30 degrees, so it feels warm when you put your hand on it, but when you lie down on it, it feels like you're lying on cool cement or something like that. It's not hard, but that sort of feeling, which should be good in summer. Anyway, if you liked this video, give it a thumbs up. Leave a comment down below, and yeah, tell me what you would do in this situation. Would you bother with something like this, or just pay for air conditioning? Anyway, till next time, see ya.